Hello once again and welcome to Arduino for Amateurs. This is episode number 26. We're going to be talking about photoresistors. So as always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the BitHaven Hackerspace. And what I'm talking about in this video is photoresistors. Photoresistors are exactly what they sound like. They are small components that change resistance depending upon the amount of light in the environment. So we're going to talk a little bit about how they work, how you build an Arduino circuit, how you read that level of resistance, and how we can use it to actuate something using the Arduino. So this little doodad here is a photoresistor. If you've purchased one of those Arduino or Raspberry Pi Pico electronics kits, there's probably one of those in there. This is a very popular component to include in those. What it is, as I said, a variable resistor. So between the two electrodes here, the two pins that you plug into your breadboard or solder into your circuit, we have this little squiggly line of semiconductor material. What this squiggly line does is it is light sensitive. The more light is hitting this component, the top of this pin here, the more conductive it becomes. And so the more conductive it becomes, the more voltage goes through it and the less resistance it produces. So you can think of this sort of like a light actuated version of those potentiometers that we used in some earlier videos. Remember, those were set up with a knob or a spindle. So when you turned that, the amount of resistance in the component increased, and we were able to use that to control things like RGB LEDs or NeoPixel rings. This is a very similar mechanism, just instead of a physical knob to turn, instead it is going to adjust the resistance based on the amount of light that it sees. Okay? Another analog might be the analog sound sensors, right, that can produce a signal based on the amount of ambient noise in the environment. In this case, it's the same thing. It's just the amount of ambient light in the environment. Now, as you can see, I've got my circuit built down here on the document camera, but I took a photo of it to put up here on the slide, kind of zoom in so it would be easier to see. So we're back to using the Uno R3. This would also work with a Nano. As we discussed in the last video, the Nano and the Uno are pretty much the same. Uno's just got these sockets, so it's a little bit easier to plug things together. Our Uno is connected to this breadboard. We have black and red wires here for ground and voltage. Ground and voltage are coming back here. We've got ground plugged into the ground pin, and then we've got 5 volts coming off the Arduino to power this rail. Here we see our photoresistor. So, and I know the leads are kind of hard to see, that's why I want to take a picture here. So we have power coming up here. It's going in one lead of the photoresistor. The other lead of the photoresistor is plugged in here in row 21 on the breadboard. And you can see there's 2 other things connected to row 21. One is this yellow wire, which is going back here to input A0. The other one is this resistor. This is a 10,000 ohm resistor that's connecting this leg back to ground. So the voltage is going to come off the Arduino here. It's going to go into one leg of our photoresistor, out the other leg, and then back to ground through this resistor. It will also have the amount of current measured here, or I'm sorry, the amount of voltage measured here through this yellow wire back to A0. So what that means is the more light this is seeing, the more conductive it is, the higher value we'll have going back to A0. Right, so if it's in darkness, it'll be 0. If it's in flooded with light, it'll be at 1024. In most environments, it'll be somewhere in the middle. Right, and the rest of this we'll talk about with the next program. But just to see what that looks like, let's go to our photoresistor basic here. So this is very simple code. I got this from a site called circuitbasics.com. They've got a great intro to photoresistors if you need more material. And the code is very simple. It sets our photo pin, that is the pin that we are connecting that yellow wire to A0. So that is the analog input that we're going to be reading from. Our setup just turns on the serial monitor, which we've got open down here. And then we have a loop. We generate a integer called light. We set that to the analog value we're reading off photo pin. Photo pin is A0. And then we print that value to the serial console, delay for 100 milliseconds, and go back to the top of the loop. Okay, so this is the simplest possible program that we could use with this photoresistor. We just want to illustrate the values that it is producing. Okay, so if I upload this to my circuit, right, and then I open up my serial monitor, you'll see here it looks like the ambient light in my office is about 390 or so. If I want to add some light, I can do that. Let me just use my phone here, and we'll see that it goes up to almost 1,000. So when I'm flooding it with light, it's becoming more and more conductive. It's giving me higher and higher values. If I turn my phone off here, we'll see it goes back down to about 380. If I cover that up so there's no more ambient light, we see it goes down to about 100, right? If I put my finger over it entirely, it might even go lower than that. Oh, I guess not. 100's about as low as it goes. There's enough light sneaking in from the sides. So the photoresistor does exactly what it says on the tin, right? It detects the amount of ambient light in the environment and then raises or lowers it as more or less light is accessible. What would this be useful for? Well, if you had plans for something like a weather station and you wanted to be able to keep track of whether it's light out or dark out. If you did something like a light display, say you wanted to put a battery-powered light string on your bicycle, right? And you wanted it to turn on or otherwise change mode when it got dark outside. That's something you can do with a photoresistor. If you wanted to have an alarm, right, you could put a photoresistor in concert with a buzzer inside a drawer. And when somebody opens a drawer, it's exposed to light, the buzzer goes off, right? There's a lot of cool stuff that you can do when you think of this as a trigger for changing light conditions. All right, our example, we're going to light up an LED when the ambient light level gets low, right? So sort of like the light on my front porch. When it gets dark outside, the light comes on. Probably a very similar mechanism that we're using there. So going back to our diagram here, where you've got this all set up with the photoresistor. So this is reading the value off the photoresistor. This green wire here, this is hooked to digital pin 7. Digital pin 7 is connected to this 220 ohm resistor. I see the lead is kind of curved back here, so it's a little hard to see, but I assure you they are both plugged in right here on, what is that, 15 or 16. They're plugged into this row of tie points. The resistor comes over here where it's plugged into the cathode for the LED, and then the anode for the LED is connected back to ground. So the digital line from here on pin 7, when it goes high, should light up the LED. So what we need to do is tie the value coming into A0 to the value of digital pin 7. And that is what we are going to do here. Oh, that's the wrong one. There we go. So again, this code was adapted from Circuit Basics. It's not exactly the same, but it's pretty close. Our photo pin is A0. Our LED pin is 7. Our main setup here, we're going to set the LED pin to output, right? So we tell the Arduino that we're not using pin 7 to read anything. Instead, we're using it as an output. Then in our loop, same thing. We have an integer called light. That light is set to the value of photo pin. If light is less than, let's set this to 300 because that's about the ambient light in my office here. If light is set to 300, then we'll set the LED pin to high. Otherwise, the LED pin stays low. And then we delay by 100 milliseconds just so we're not constantly ramming through the loop. All right. Check this to make sure our syntax is okay. All right, everything is looking good. And then we will hit upload. All right, done uploading. So the LED is not lit. If I add more light to it, you can't really see on the thing, but the LED remains unlit. However, if I cover it, it should light the LED up. There we go. See? So the LED lights up when it doesn't have enough ambient light in the room. Again, we could use this to make an alarm or a light sensor or a porch light, anything like that where we want to activate something using the Arduino when the light goes out in the room. We could use those IR remote broadcasters that or transmitters rather, that we saw in some earlier videos to turn on the lights in my office when it starts to get dark outside, right? There's a lot of cool automation stuff that you can do with these photoresistors. And as I said, you've probably already got one in your box of parts. So go ahead, play with it. If you come up with a cool idea, please put it in the comments. Thanks so much. Talk to you soon.